Okay, let's go over an example of the application of conditional probabilities, and we'll use Paul Wessel's example 1-8. And the situation is a group of researchers discover an unusual or a new fossil at the mouth of a riverbed. And so they discover the fossil somewhere downstream, and it's a very exciting discovery, and they want to go find more to learn more about it. But the problem is, so the objective is to find the source of that fossil, and the problem is that there are two possible locations where there are known to be fossils. There is one area, B1, Basin 1, having an area of 180 square kilometers, and another area, B2, that's slightly smaller. But they're both big areas, so you want to sort of minimize the amount of effort you put into this. So we need to help them decide which basin they should send their graduate students and undergraduate students to go look for these valuable fossils. But another slight complication is there's lots of different types of fossils in both areas, and only some of them are marine. So let's say A corresponds to the existence of a marine fossil. B1 corresponds to Basin 1. B2 corresponds to Basin 2. So to help these researchers to find out which place to search first, we need to evaluate the probability that given there's a marine fossil, they should go to Basin 1, versus the probability that given a marine fossil, they should go to Basin 2. Okay, the conditional probability of a marine fossil, what's the probability of Basin 1 versus Basin 2? Okay, so let's build the information we need. So the probability of Basin 1 for all fossils is, well, it's 180. Let's say it's proportional to the area, just to be simple. So compared to the total area, that has a probability of 0.64. The probability of all fossils coming from, well, any fossil found downstream, the probability that it came from B2 is 100 over the combined area of the two basins, and that's equal to 0.36. Okay, so let's say that we know from prior studies that given in Basin B1, 35% are marine. Right? Given we're in Basin 1, the probability of a marine fossil is 0.35. And given that we're in Basin 2, the probability of a marine fossil is 80%. So 80% of the fossils in Basin 2 are marine. So again, we seek these two quantities. So let's use the equations that we looked at in the last video and see what we get. So the probability of a marine fossil coming from Basin 1 is equal to the probability of A comma B1 times the probability of B1 all over the probability of A. Okay, so the probability of a marine fossil from any basin is PA. And remember, from any basin we have to sum up all the possible outcomes of a marine fossil, just as we talked about. Sorry, all the possible causes, or in this case the possible sources of a marine fossil. So we would write the probability of A comma B1 times the probability of B1 plus the probability of A given B2 times the probability of B2. And if we plug in the numbers that we showed in the previous slide, we get a probability that given a marine fossil, and where we downstream, the probability of all marine fossils coming from basin B is 0.44. And we can do a similar exercise for basin 2, and we find that the probability of any marine fossil coming from B2 is 0.56. So we can give an educated guess to our friends that they should go look in basin 2. And, well, luckily for them, it's the smaller of the two.